This lesson's on 10.8, which you may have guessed, now we're doing volumes of pyramids and cones. And again, it's a lot easier than the surface area. So in this case, we have a very similar equation to the volumes of prisms and cylinders, but instead, because it's coming to a point and not a flat surface, we add the 1/3 times space times height. So in this case, we're not using the slant height, we're using the height from the center of the base to the point. So when using this equation, if we're using this example on the right, first we find our base, which since it's a square, it's 30 times 30, and the height is 17 meters. So 1/3 times 30 times 30 times 17, which gives us 5,100 cubic meters. You can either write it as cubic meters written out, or you could say meters cubed. Either is correct, they mean the same thing. So that's pretty easy, right? You just have to make sure you're using the right height, and if they give you the slant length, that you don't use that. You're using the height. What if it's the volume of a cone, though? If we have this situation where the height is equal to 15 feet and the diameter equals 9.5 feet, how could we find it? Well, first off, we know the radius is half the diameter, so our radius is going to equal 4.75 feet. So we still use the formula volume equals 1/3 times base times height, but the area of the base here, because it's big B, is the area of the circle. So we have 1/3 times pi times r squared, which is 4.75 squared, times the height of 15. So then we can multiply those together. Make sure you do the squared part first before multiplying it by the other terms. And we're left with 354 cubic feet, or feet cubed. That's all there is to this lesson. So you're going to be happy because look, we're done. Tomorrow we're going to do practice problems in class. Just make sure you've really written down these formulas and go ahead and show what the substitute would be when you put in the area for our big B, or the area of the base. That's all for this lesson.